Guys, welcome back to my video, and in this video we'll be doing a complete walkthrough of the May 2019 paper, and this is focusing on paper 1H of the International or IGCSE syllabus for Edexcel. Okay, and for you guys who are new to my channel and new to my videos, we always go through the whole paper, and I basically do a complete walkthrough and a breakdown of every single question. Yeah, so literally showing you guys the ropes, how to do things quickly and efficiently, and you know, try use your calculator skills, because this one is like highly recommended. You should always use your calculator, even for the easy markers. Yeah, trust me, you don't be dropping any single marks. But yeah, let's scroll down and see what we have. So as always, in every single paper, you're given a formula sheet. Then we're just looking at the higher tier, yeah. And the good thing is, they pretty much give you all the best formulas. You know, they give you the triangle formulas, quadratic equation, which is like literally so important, areas of trapeziums, volumes, and yeah. So all the hard ones are here. They're missing a couple, ones. You know, I'm not gonna lie. There is a few ones they're missing, but thankfully they're not too bad. Okay, these are the hard ones to memorize. So without further ado, guys, let's just jump into the first question. Yeah. So what do we have? Number 1. So show that 4 2/3 divided by 1 whole and 1/9 equals the right hand side. So for these kind of show that questions, the trick is, when it comes to any fraction problem, is to rewrite this mixed fraction as improper. Okay, and this is how we do it. To convert this first fraction to improper, a single unified fraction, I would always multiply the whole number at the bottom, so 4 times 3, which is 12, and add it to the top. So 12 plus 2 is 14. And then we copy the bottom, so 14 over 3. Next, divide. And then repeating for the second one, you got 1 times 9 is 9, plus 1 is 10, so it'd be 10/9. Now, because you're dividing fractions, you always should change it to a multiplication sign here. So that's usually a trick. Go from divide to times. And to do that, all we do is literally copy the first one, change this to a times, and then when you do that, you must flip the second fraction. So 10 over 9 becomes 9 over 10. And that's it, guys. And all you gotta do here now is literally just whip out your calculator. Just do 14, 14 over 3 times 9 over 10. And when you do that, guys, you're literally going to get a fraction which says 21 over 5. And you're pretty much done here. All you can do now is literally just write the final step. Because what they ask you now is how many 5s go into 21. Well, you can kind of see that you got 4 wholes and you got 1/5 left over. Or just copy the answer. And then you're done. So, number 2 now. It says that Jelena left her home at 10 a.m. to cycle to a park. On her way to the park, she stopped at a friend's house and then continued her journey to the park. Okay, so that's kind of what the whole distance time graph is about, yeah? Like, this is her home right here, so it's always good to label. Your home begins here, and it tells us that she cycles to the park. So we're just going to assume that, okay, oh yeah, and she stops at a friend's house. So we can kind of assume that because she ain't moving here, this must be her friend's house. Okay, so somewhere on that place. Friend's house. And then the park is definitely at the top here. Park. Okay, here is the distance times graph for a journey to the park. Cool. So, on her journey to the park, did Jelena cycle at faster speed before or after she stopped at her friend's house? Give a reason for your answer. So, all they really want to know is which line is more slopey. Okay, which one has a greater gradient or greater slope? Now, to find the gradient of a line, it's actually not too bad. All you do is just find, and then we can just write here, the change in y over the change in x. And by the way, guys, the gradient refers to the speed, yeah, so the speed s. Now, let's just pick 2 points. I'm going to pick the gradient from here to here. So we can say that, well, using the change in y, it's going to be the change in distance. So from 0 to 15 is 15. And the change in time is from 10 a.m. to 11 a.m. So that's 1 hour. So you can kind of see that 15 over 1 is 15. Okay, so she traveled at 15 meters per second, I guess. Is that her speed? 15 meters per second. Yeah? No, 15 kilometers per hour. 15 kilometers per hour. That's the speed from to her friend's house. Whereas from her friends to the park, again, just pick 2 points. We pick this one and that one, yeah. So just looking at the distance, she was at 15. She went all the way up to 24. So she traveled 9, yeah. So we can say that the speed for this one was 9 over, and then we know the time it took was from, 11:15 all the way up to 12. So that's 45 minutes, yeah. And because you're working in hours, 45 minutes is the same as 45 minutes over 60. That's basically the hour equivalent. Now, if you put this in your calculator, so you're going to have basically 9 over that fraction, you should get exactly, what's it called? 12 kilometers per hour. So the answer would be, she actually rode faster at between her home to her friend's house. Whereas between the friends to the park, it was a bit slower by 3. So that's what you'd write. You just write these figures in, you're done. Now for the second part, it said Jelena stayed at the park for 45 minutes. Okay, so let's just put that there for a second, yeah? You're at the park, and we know that, every little block is 15 minutes. So she must have stayed up to here or something, yeah? So that's, what's it called? Yep, 12:45, 45 minutes. She then cycled without stopping at a constant speed of 16 kilometers per hour from the park back to her home. Okay, so this is just like a quick thing, going from the park straight to the home. So let's have a look. 16 kilometers per hour, yeah? You're at 24 right now. So that means like currently, if we use the speed equals distance over time, we know that there's 24 kilometers to get to home. So what we could do, we can put t as a subject. So to do this, always multiply t across and divide by s. So you have something like time equals distance over speed. Well, we know the distance from the home is 24 kilometers. We know she traveled at 16 kilometers per hour. So dividing both these numbers, you should get a nice time of 1.5 hours. Okay, so it took her 1.5 hours to get home. Okay, just keep that in mind for a second. Blah blah. Show all this information on the distance time graph. Okay, so we have to plot this. That means from here, we're going to go 1.5 hours. So if we're at 12:45 right now, let's write 12:45. And it takes you an hour and a half to get home. So from 12:45, add an hour, it will be 1:45 p.m. And then add a half an hour, it will be 2:15. So she's going to get home around here. So what you should do, guys, is use a ruler, yeah? But because I don't have a ruler, I'm just going to do like a little quick dotted line. Yeah. Yeah, so it should be a nice straight line. And that should cover this part. Now, for C, we need to work out Jelena's average cycling speed in kilometers per hour for the complete journey to the park and back. Do not include the times when she was not cycling in your calculation. Okay, in other words, don't talk about the times where you are not moving, like the dark red lines. So we asked ourselves, alright, how far did she travel altogether and how long did it take? So what we can say that the speed equals the total distance over the total time. Well, if you think about it, we know that the park was 24 kilometers away. And also to get home is another 24 kilometers. So double that, you should get 48 kilometers, right? Now time-wise, we know she started at 10 a.m. She arrived at 2:15 p.m. So that's about 4 hours and 15 minutes. So you could say that's 4 hours and 50 minutes. So that's basically 4 plus 15 over 60, yeah? However, we need to remove the times that she didn't move. So she stayed at friends for what, 15 minutes, at the park for 45 minutes. 15 plus 45 is an hour. So you can subtract an hour. So essentially it's just going to be 3 hours and 15 minutes she spent. So putting that in the calculator, well, 3 plus 15 over 60, that's 3.25, guys. 3.25 hours. So therefore, our average speed was 48 over 3.25 hours. And yeah, and then again, smashing on your calculator, you should get an average speed of approximately, what is it? And I don't know, maybe they want one decimal place, isn't it? To one decimal place, it should have been 14.8. So 14.8 kilometers per hour. And yeah, that seems about right, I think. Because, she started kind of like at 15 over here, dropped to 12, and went to 16. So the answer has to kind of fall somewhere between those numbers. But yeah, that's number 2 done. So let's move on to 3. Alright, algebra. I actually love algebra. So 3a, simplify e to the 9 divided by e to the power of 5. Well, when you're dividing terms, you just subtract the powers. So 9 take away 5, guys, is just e to the 4. And that's it. B, simplify y squared or bracket up to the power a. Well, when you got something in this form, when you got bracket and then there's 2 powers next to each other, you essentially just multiply the 2 of the a. So it'd be 2 times a, which is 16. So your answer would be y to the 16. Okay? Now C, expand and simplify this double bracket. Well, when you have double brackets, all you gotta do is literally draw arrows because it helps. So I would say something like this. I always do x times x and x times minus 2 and then 9 times x and 9 times minus 2. Okay, and then just do it step by step. If you do that, you should have an x times x, which is x squared. X and minus 2 gives us minus 2x. 9 times x is plus 9x. And finally, 9 times minus 2 is minus 18. And as always, you always have to tidy up the middle two terms. Yeah, and if you're not sure what minus 2x plus 9x is, just put that in your calculator. Write minus 2 plus 9, you're just going to get a nice 7x or just 7 in your calculator. And therefore, writing the whole thing out, you therefore go x squared plus 7x minus 18. And yeah. And for D, factorize fully that expression. Okay, so to factorize something, you just got to look at both of these terms here. So the first part and the second part, and then just ask yourself, what do each of these things look like? How many P's are there? How many C's are there? And what times table is 1620 in? Well, let's do it step at a time. For the numbers, we've got 1620. We can see that they're both in the 4 times table, yeah? So we just literally divide 4 out. So we put 4 outside. We look at the letters C, and we ask ourselves, what is the maximum they both have? Well, this has a single C, and this got 4 C's, so they both have at least a C. That's for sure. Again, looking at P, you got 2 parts of P, so P squared, and you got 3 parts of P. So they both have at least 2 parts of P, so P squared. Okay, and then you just get the bracket open. And now, because you took out this common factor from both, because that's what you're doing, you're finding the common factor, now you just say, okay, if I divided this term by 4c and p squared, dividing 16 by 4, you just left with 4. Because you took out c from c to the power 4, you left with 3 parts of c. And because you took out the whole p squared, well, that's gone. Now, that's done. Put a plus. Now, looking at the second term, we divided the first part by 4. So 20 divided by 4 is 5. We took out c, so that's gone. And you took out 2 parts of p, so p squared taken from p cubed. You just left with a single p. And yeah, guys, this should go here. And yeah, that's 3 done as well. Now, alright, number 4. So complete the table of values for y equals x squared minus 3x minus 1. Alright, so I'm not gonna lie, these questions are really okay. Because you got a table of values, and all you gotta do, guys, is just replace your x values with these numbers. Like replace x say with minus 2, and then you just get an output of y. Okay, so for example, in your calculator, we can write this. Replace x with minus 2, wrap in a squared, take away 3 times minus 2, take away 1. Now, you kind of have to do this step by step here. So, just to show you guys, put this in the bracket, you get 4 plus 6, which is 10, take away 1, and it gives you 9. So, that's where this value goes. Now, if you do the same thing with minus 1, replace x with minus 1, you're going to get 1 plus 3, which is 4, take away 1, which is 3. The good thing is, again, because you've got a calculator, you don't have to do this. You just put this all in and it'll give you an answer. And for the rest of them, when x is 1, you got 1, take away 3, which is minus 2, take away another 1, and it gives you minus 3. And finally, for 3, you got 3 squared, which is 9, take away another 3 times 3, which is 9 take away 9, which is 0, take away 1, and you get minus 1. And yeah, I think that covers it all. Now, on the grid, draw the graph of basically what we just did for all values of x from minus 2 to positive 4. In other words, plot these coordinates in. So I might just actually zoom out a bit. Okay, so let me just, okay, so for the first part, minus 2 to 9. So we just go minus 2 on the x and shoot up to 9. Should be about here, yeah? For the second part, we got minus 1 to 3. So minus 1 all the way to 3. Next part would be 0 to minus 1. So you start at 0 and you drop to minus 1. So it should be here. So, oh yeah, this is going to be a quadratic graph because it's an x squared. So we're expecting literally a U shape. So the next one would be 1 and minus 3. So 1 across, drop to minus 3. And I think it starts showing up soon. Yep, 2 is also minus 3. So move across, minus 3. Next one would be 3 minus 1. So over here. Next one is 4 and 3. So here. And yeah. And now I believe you just connect them here because it's a U-shaped graph. So connecting them, this is going to be the hard one. Make sure you don't use a ruler, guys, because you have to do it freehand. Oh my god, that is so horrible. Yeah, it takes some time, but you just gotta be so careful. Okay, okay, you know what? Oh, this is tough. It's tough to do on a computer. Ooh, yeah. So just try your best and make it look as neat as possible, yeah? And try and actually hit the point, not like me, yeah? Wow, and that's it. That's literally the end of the question. You don't do nothing with it. So, moving on to 5 now. Becky has a biased six-sided dice. The table gives information about the probability that when a dice is thrown, it will land each number. Now, quick thing about probabilities, guys. We should always know, like, before we even look at a question related to probability, we should always realize that the sum of all these probabilities always equals to 1. So that's if you add them up here. Now, before we even do this question, let's just add them up right now. So we got 2x plus all of this, so 2x plus 2x plus 3x plus an x. That's 4x, that's 7x. We have 8x in that equation. Adding the numbers here, you got 0.18 plus 0.26. That actually gives us 0.44. So this means that you got 8x plus 0.44 must equal to 1, yeah? That means if we solve for x here before we even do this question, so we can subtract 0.44 across. So 1 take away 0.44 will give us 0.56, and then dividing that by 8 because you just want to find x in it. That means x equals 0.07. Yeah, so yeah, and that's pretty much what it gives you. So technically, if you update the table, this is now 0.07. This is 3 lots of 0.7. So 3 times 0.07 is 0.21. This is 0.14. This is 0.14. Okay, good. Now, continuing the question, guys. It says Becky is going to throw the dice 200 times. Work out an estimate for the number of times that the dice will land on an even number. Okay, even number in this case refers to, like, well, 2, 4, and 6. So we can see that to get a 2, you got an 18% chance. To get a 4, you got 21, and 6 is 7. So that means the total chance would be 18 plus 21 plus 7. So you put that in the calculator, 18 plus 0.18 plus 0.21 plus 0.07, you should have a total chance of 0.46. And of course, she's going to roll it 200 times. Just multiply that by 200, guys. Because you want to find the expected number of times she's going to get an even number. And therefore, just again, in your calculator, you should get a result of 92. And yeah, guys, that's literally done. That's all you got to do. And again, that's 5 done. And trust me, and see, and you bag a lot of marks. These kind of problems, they're not so bad because they kind of mix algebra with your numbers. And just knowing these little basic probabilities, like basic rules, like sum of them equal 1, you can kind of just get everything done instantly before you even start a question. Yeah. So, next one, guys, number 6 now. Alright, so 6. The diagram shows a solid cuboid made from wood. Okay, so we got 12, 8, 5. So this is your cuboid. Now the wood has a density of 0.7 grams per centimeter cube. Okay, so grams is a mass, centimeter cube is a volume. So actually, density formula is like this, guys. The density equals the mass, which is the gram, over the volume, which is the centimeter cube. And it's nice because they actually kind of like indirectly mention it. Density equals grams over centimeter cube equals mass over volume. Now, question is, work out the mass of the cuboid. Well, that's not bad. That just involves rearranging this formula. So to find mass, multiply volume across. So this means you got volume times your density equals your mass. Now, what is the volume? The volume of this cuboid is just literally you multiplying all of these 3 numbers, yeah? So in your calculator, you're going to have 12 times 8 times 5. This means that the volume is 480 centimeter cube. And well, we know what the mass is. The mass is volume times density, so it'll be 480 times 0.7. This means that the mass is now going to be 336 grams. Yeah. Alright, 7 now. Write 5.7 times 10 to the power 6 as an ordinary number. You know I love these questions, guys, because you got a calculator. You could just write in and you get an answer. But in reality, you don't actually need it. So to rewrite this as an ordinary number, in other words, like a natural number which you see, a very simple number, 10 to the power 6 literally means you must have 10 values, 6 digits after the 5. So think of it as this. You got 5, and then you got 7, which is 1 digit, and then you have 5 more digits. So 0, 0, and then 0, 0, 0. So these are your 6 digits. So that's your answer. So just 5,700,000. Nothing to it. Now, B, write 0.04 in standard form. The trick is, to write something in standard form, it's just basically like part A. So it's going to be the first non-zero digit, which is a 4. Then you always write times 10 to the power something. Now, because you've got a bunch of zeros before the number, you just count how many zeros are there before it. Well, you got 3. And because it's like before the digit, it'll be negative 3. And that's it. Now, lastly, work out this one. Again, this is kind of good because you just copy that straight in your calculator. So I'm going to go ahead and just copy it now. So make sure you firstly use the fraction button in your like Casio calculator. So yeah, guys, make sure you have a Casio. And the kind of Casio you should, like I personally recommend, would be any of the GX ones. Like, I don't know, was it 83 or 85? Yeah, so just like a standard Casio calculator. So yeah, just pop this into your calculator. So it'll be 2 times 10 to the power 4 plus 3 times 10 to the power 5. Again, all of this is going to be in the top half of the fraction. And on the bottom half, 6.4 times 10 to the power of negative 2. And you just get an answer, well, my calculator, which is 500,000. So that's actually reads 5 million. So you should get an answer of 5 million. It doesn't say what form to put, guys. So don't bother putting standard form because it doesn't say. But yeah, that's your answer. If you want to put in standard form, well, you got 6 zeros in front of 5. So it'd be 5 times 10 to the power of 6. And yeah, either one of those answers is cool. Now, number 8. So yeah, guys, so far the paper hasn't been bad, has it? I feel like this is one of the, so far, thank God, we can't say it's like very easy, but it's been, like, in my opinion, better than some of the other papers we've seen because they've been quite challenging. I'm not gonna lie, they've been challenging. So thank God, this is not the worst one we've seen. Now, number 8. So, on the 1st of January 2016, Lee bought a boat for $170,000. Alright, cool. The value of this boat depreciates by 8% per year. Okay, so what this means so far, you had 170,000 and it's gone down by 8%. So what that means is that you always write a multiply. So it's always 1 plus or minus a rate. Well, if it goes down by 8%, it's going to be 1 minus 8%. 8% is just 0.08. Okay, so that means it's gone down by 0. So the multiply is now 0.92. So that's what we need to write. So far we have 170,000 times 0.92. Okay, work out the value of the boat on the 1st of January 2019. Okay, so notice this. You were at 2016. It depreciates every year by 8% to 2019. So that's 3 years. So it'll be 0.92 to power 3. So you always power this by the number of years. And yeah, give your answer correct to nearest dollar. Nice. So just put that in your calculator. And if you do that, guys, you just copy exactly as you do. You should get 132, so $132,376,000, 0.96. Now it says give your answer correct to the nearest dollar. So round it to the nearest whole number, yeah? So if you look at 96, round it up, this one becomes a 7, and that crosses out. So to write it neatly, we got $132,377. Okay, not bad. So it's kind of dropped its value. And that's like cars. Cars, boats, everything loses value every single year. And yeah, that's something you got to deal with, unfortunately. Alright, 9. So the diagram shows a shape made from a right angle triangle and a semicircle. Okay, so you got semicircle and a right angle triangle. And okay, so they got same lengths. So technically, when you got a triangle with same lengths, this means this is an isosceles triangle, yeah? And for an isosceles triangle, guys, what that also means is that 2 lengths are the same and both angles are the same. And another thing is, we've got a 90 degrees angle here. So if this is 90, we know a whole triangle adds up to 180. So these two must add up to be 90 each. And because they're the same, they have to both be 45 degrees. Okay? Because 45 plus 45 is 90, plus 90 is 180 degrees. Okay, cool. So we actually just literally just figured out just from the fact that we got same lengths and a right angle triangle. Cool. Now, the rest of the information is this. We've got AC is the diameter of a semicircle. Okay, so here's your diameter, meaning halfway across must be the radius. So halfway across the radius. And BA equals BC, we know that. Angle ABC is right angled. work out the area of the whole shape. Alright, cool. So looks like we understand what's going on. Now, what I personally like to do, guys, is that I like to pull out some shapes, yeah? I like to make it easy. So let's pull out this triangle for a second, okay? It doesn't have to be this like nicely drawn, by the way. It's not a big deal. So what we have, we got a 6, we got 45, and we got, let's say, 90, yeah? And 45 as well. Now, my personal tip here is that we need to firstly work out the area of the semicircle and the area of the triangle separately. Well, to work out the area of a semicircle or a circle, we need to know the radius. We actually don't know the radius, and by the way, guys, the radius is not 6. That's just the length, even though it looks like a sector. So to work out this radius, my tip is to firstly work out the whole length. And to work out the whole length, you just pick a triangle rule. I'm going to pick the sine rule because I think that's easier to use. Now, let's just call the unknown length x. And according to the sine rule, you just match length of angle. So we're going to say, okay, according to the sine rule, we've got x over its opposite, which is 90. So x over sine 90. And then we match to another pair. Let's say 6 over its opposite, which is 45. 6 over sine 45. And to get the result, all you do is make x a subject, so times sine 90 across. So we're going to have x equals 6 over sine 45 times sine 90. Now, in your calculator, if you do that, and you just be careful about it, you should get a result of you should get a result of exactly 6 root 2. Okay, so you get a third. Now, whatever you do, guys, try avoid changes to decimal, yeah, because we want to kind of keep it like that, because that way you can round your answer properly. So that means if the whole thing is 6 root 2, half of 6 root 2, so divide your answer by 2, that means the radius is just 3 root 2, okay? It's just half of it. And well, to find the area of a circle now, area of a circle is always pi r squared. And because you got half a circle, it will be all of that divided by 2. Now, putting this in your calculator, you know the radius is 3 root 2. So the area will be pi times 3 root 2. So wrap the whole thing in a bracket, squared divided by 2. And if you do that, you should get exactly, well, you can just write 3 root 2 squared over 2. And then times your answer by pi, you're going to get exactly 9 pi. So your answer is 9 pi. Or as a decimal, you're going to get 28.27. Again, I prefer the 9 pi form, yeah? So that means your final answer, guys, is going to be what? 9 pi plus, and oh yeah, also we need to find the area of a triangle, isn't it? So to find the area of a triangle, I should write it down here. Area of a triangle is always half AB sine C. And to understand that half AB sine C, just redraw a triangle. You literally need a length AB and an angle between it, C. Well, we know the angle between it is 90. We know A and B are 6. So it's going to be half times 6 times 6. So 6 times 6. And then sine 90. And putting that in your calculator, so it'll be 1 over 2 times 6 squared times sine 90. It's just 18. Conveniently, it's just 18. So guys, our total area is therefore 9 pi plus 18, yeah? So total area is 9 pi plus 18, and that should give us one decimal place here. That should give us one decimal place, 46.3. And yeah, guys, you're literally done. That's number 9 covered. All right, moving on to number 10. So we got a equals 2 to the power n times 3 times 5 to the power m. Okay, so looks like we got a couple of prime numbers here. Now write 8a as a product of powers of its prime factors. Okay, so this kind of question is literally telling us that we have a already, and now they want to find 8a and rewrite it as products of powers of prime factors. So first things first, let's multiply this whole equation by 8 and see what 8a actually gives us, yeah? So we have 8a, that now gives us the same expression, yeah? The only difference now is that we're now multiplying all of this by essentially 8, yeah? And the only problem here is that 8 itself is not a prime number, so we actually just have to change 8 to a prime number. And to do that, well, if it's not, like, sometimes not really obvious to see, I would just use the prime factor tree, yeah? And I'll just keep breaking it down to prime factors. Well, 8 itself is the same as 2 times 4, and 4 is the same as 2 times 2. And then you always circle the last legs, yeah? That's like what we always do. And then we come to realize that 8 is literally the same as 2 to the power 3, okay? If you already knew this, then we could just do that straight away. So technically, we already have 2 to the power n, and now we have 2 to the power 3. So altogether, if we just like add them up, because when you multiply things, you add powers. We essentially have 2 to the power of n plus 3. And we just copy the rest, times 3 times 5 to the power m. And that's exactly what they're looking for here. Yeah, so 11 now. It says C equals B minus A equals 6, correct the nearest integer, so it's being rounded like with some decimal values, and B equals 15, correct to the nearest 5. Okay, this is an interesting one. Now work out the upper bound for the value of C and show you working clearly. Okay, so what we should do is just firstly bound these up here. So we can say that for A, and we can use like inequalities, we have a lower bound and an upper bound. So lower bound values go here, upper bound values go here. Let's do the first one second, yeah? Now, if we're going to round 6 to the nearest integer, this means that it would have to be less than, let's say, 6.5. Usually the trick here, guys, is that we always typically add a 5. That's kind of what we do. And to round up to 6, it would have to be 5.5. Okay, so it's always rotating between 5.5 to 6.5. Now, B is a bit different here because this is something we don't usually see. So it says 15 correct to the nearest 5. So it looks like it's going to be rounding in terms of 5s, yeah? So what that would actually mean is that the highest possible value could have been is that instead of it being, I don't know, like you'd expect it to be 15.5, but that's going to round it to the nearest ones. So we have to kind of go a bit further. So instead of halving like the integer, like halving 1, we need to halve this 5 up and down. So half of 5 we can see is 2.5, and then we're just going to plus minus to 15. So plussing it to 15, you're going to get 17.5, and then minusing it to 15, you're going to get 12.5. Okay, it's kind of the same thing. If you look at the first one, 6, instead of them saying round 6 correct to the nearest integer, they could say round 6 correct to the nearest 1, which is the same thing. And if we halve the 1, you get plus minus 0.5, and that's where you add or minus to your 6. Okay, that's actually probably a simple way to do it, in fact. So we can use this for future questions as well. Now, let's solve the actual question, yeah? So they want us to work out the upper bound for the value of C. Alright, an upper bound. Now, when you're subtracting things, yeah, to work out an upper bound, what it wants you to find is literally the greatest distance it can be. Now, to get the greatest distance, you need to get the biggest possible value of B and the value of A, which is furthest away. In other words, the smallest value, yeah? So it's going to be C equals the upper bound of, what is it, B minus the lower bound of A. So we just put this in a calculator. You got 17.5 minus A would be 5.5. Now this ain't too bad. So 0.5's cancel out. 17 take away 5 is 12. And yeah, I think this is the answer. Yeah, so let's move on. Now 12. Factorize 2x squared minus 7x plus 6. Okay, yeah, let's try this out. So this is a quadratic equation. Now to factorize quadratics, you always use a double bracket. Yeah, that's the first thing. Now, one of the rules is you always look at the coefficient of x squared, the value in front. It says 2x squared. So we always think two numbers are multiplied to make it. Well, it can only be 2x times x. That's just how it is. And now we look at the last digit, 6. And then we ask ourselves, what two numbers multiply to make 6? So we just list them up. We got 1 and 6. And we also have 2 and 3. Okay. Now here comes the main part, yeah? So because we got a coefficient of 2 here, yeah, so it's got 2x squared, we need to literally multiply one of these digits by 2 and then add or minus them, the result, to get a 7 or minus 7, yeah? So let's think about it. If it was just like 1 and 6, you know, if we multiplied 1 by 2, we're going to get 2 and 6. Well, 2 and 6, you can never get 7 out of it if you add or minus. If you times 6 by 2, you get 12. Well, 12 and 1 you can never get. So we're going to just cross this out. We can't use that. Now for the second case, if you multiply 2 by 2, you're going to get 4. So 4 and 3, again, actually you can. 4 and 3 you can. So you can say, if you multiply this by 2, in other words, 2x times 2, and this has to be 3, we can actually get a 7x, because minus 4x minus 3x gives us a minus 7x. So in fact, they're both negatives. And yeah, it checks out. That's what we got to do, guys. Now for part B, we got to solve this equation here, and we got to show clear algebraic working. So every time we get an algebraic equation, guys, the first thing you want to literally hit your mind is you got to clear that fraction, yeah? The fraction got to go. And for it to go, you need to literally multiply the whole thing by wherever it is. In this case, 3. So if you multiply 3 across, what actually happens is that the 3 disappears. So you got 4m plus 9. And because this side doesn't have a 3, you just multiply the whole thing by 3. And you end up with 21 minus, well, 3 times 2m is 6m. Now this is just a case of just moving things in the right place. So we want to end up getting m equals something, yeah, some value. That's our target. And to do that, we need to move the m terms to the left and the number terms, the one without m's, to the right. So let's do it. Let's move minus 6m across, and if you move things across the equal sign, you flip the sign, so you do the inverse. So minus 6m move across becomes a plus 6m. 4m plus 6m is 10m. If you move plus 9 across, becomes a minus 9. 21 take away 9 should give us 12. And that's it. And then to get an m, you just divide 10 across. So m equals 12 divided by 10. Simplifies fraction, you get 6 over 5, or 1.2. Both is good. And yeah, 4 marks for that. Ah, wow. Okay, cool. That's actually a lot. Now see, write the fourth root of y over y in the form of y to the power b. Okay, this looks intimidating, but it's actually not. So this thing here, you just have to write index form. Well, the fourth root of y literally means, well, instead of y to the power 4, it'll be y to the fourth, 1 over 4. And then we have to divide that by y. And remember, y on its own is just y to the power 1, because it's just a single power. Now, if you remember the rules, if you divide two terms of the same base, you subtract its powers. So 1 over 4, so quarter, take away 1. If you're not sure what that is mentally, just use a calculator. You should get minus 3 over 4. And that's your index form. And that's it, guys. That's this question done. So, okay, 13. Alright, so tree diagrams now. So it says in group C, there are 6 girls and 8 boys. And in group D, there are 3 girls and 7 boys. Now, a team is made by picking at random one child from group C. So you got one out of these guys. So just to help, let's just make a total number of both here. If you got 6 girls and 8 boys, then you got 14 students in that class, yeah? So 14 students. Whereas in group D, you got 3 and 7, so 10 students. Okay, so it's always good to kind of like total these up, yeah? Because we're using probabilities here. Now, next part is, it says a team is made by picking at random one child from group C and one child from group D. Alright, cool. Complete the probability tree diagram. Okay, so we look over here. We say the probability picking a girl and a boy from group C. Well, we know that we've got 6 girls out of 14, so you just write 6 out of 14. And we know we've got 8 boys here, so 8 out of 14. Cool. And then on the next group, we have group D. Girl-wise, we have 3 out of 10. Boys, 7 out of 10. And this is just the same tree. So 3 out of 10, 7 out of 10. Cool. Now, work out the probability that there are 2 boys in a team. Okay, so for 2 boys in a team, you just follow the boy tree. So in other words, you just go through here. So the result would literally just be 8 over 14. And when you chain things up, you multiply, yeah? 8 over 14 times 7 over 10. And conveniently, you can put this in your calculator. So 8 over 14 times 7 over 10. I got 2/5. That's my answer. Don't know why that's doing there. So yeah, just leave it as a fraction, guys. Don't write decimal. You don't have to. They're not picky like that. Yeah. Now for the next part, it says after the first team has been picked, a second team is picked. Okay, so I'm trying to understand it myself. One child is picked at random from the children left in group C. Okay, so I think we're trying to say when you pick a team. Okay, so what that's from my understanding. So you pick a child. You initially had 14 students and 10 students. That's team 1. So when you pick a student, you now end up with 13 students here and 9 students left, and that goes to team 2. So of course one from that group. Now it says here that one child is picked at random from the children left in group C, and one child is picked at random from the children left in group D. Now work at the probability that there are 2 boys in each of the 2 teams. Man, where's the girls at? Why are they not picking girls? So let's have a look. We already said initially that when they pick 2 boys, we got 2/5, right? So we can say, all right, for the first set, probability of picking, let's say, first team of boy and boy, we got, what's that? So this is the first set, yeah? With this property was 2/5. Now if we think about, because you did that already, you're now down to 7 boys out of 13, so that's the second set. So this is the second set now. Property of picking boy and boy, you're now down to 7 out of 13 for the first group, and we had 7 previously, we now got 6 out of 9 for the second group, times 6 out of 9. Okay, and here if you type this in the calculator, you should get 14 out of 39. Okay, so we're almost done now. So we just found the properties of this happening. And we can say, therefore, to work out the property that there are 2 boys in each of 2 teams, so now finally we just put them together. If you multiply both these together, because that's what they want, you'll get a final answer of 28 out of 195. And yeah, and that's your answer. And for people working in decimals, you should have got 0.14. I'm going to say 3 decimal places, 144. Something like that, yeah? And that should be it. Now, 14. So it says that we got this symbol, which is actually called the universal set, by the way. This means all the numbers we're allowed to use in this question. So it says that we can only have positive integers less than 20. So if I had to just put this out, positive integers means whole numbers, which are positive, like 1, 2, 3, all the way up to 18, 19, but not 20, yeah? So these are the 19 numbers we're going to use. Second one, we have set A, which is part of the universal set. It's all x values less than 12. So just, we can say A is basically 1, 2, 3, all the way up to 12, so up to 11, yeah? You don't have to put all the numbers, but it's good if you kind of break it up a bit. And for set B, it's between 7 and 16, but includes 7. So it's going to say, it's going to be 7, 8, 9, dot, 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 all the way up to 15. Remember, it doesn't include 16. Now, part A, it says that we need to list the members of A intersecting B. So this symbol here means numbers they have in common. Well, if you look at the numbers, this goes from 1 to 11, that goes from 7 to 15. The only numbers it has in common is between 7 all the way up to 11. So the answer here would be 7, 8, 9, 10, 11. You don't actually have to use a symbol. This is just something we like to collect our numbers in. You don't actually have to write in your exam. Now for the next part, we have a new set C, which is a set such that A is a subset. Is that again? Oh man, I don't forget. C is a subset of A, meaning C is actually inside of A. And the number of terms of C is 3. So, for example, like we have 19 terms here. This means there's only 3 terms of C. So C is basically consists of 1, 2, 3 numbers. Now, given that all members of C are even numbers, so far C is a set of A, so it could possibly be 2, 4, 6, 8, 10. So let's write it down. So it could be 2, 4, 6, 8, or 10. It's only be 3 of them. List the members of one possible set of C. Okay, cool. It's actually not bad. You just pick any 3 random even numbers. So let's just say 2, 4, 6. Yeah, and that's it. Nothing to it. Now, 15. Use algebra to show that the recurrent decimal gives you 14 out of 55. Okay, recurrent decimal. So when they say to show this, you have to use algebra. Like, that's the only way to do it. And to do it, we kind of have to basically call this thing x, yeah? It's recurrent decimal. So we could say, all right, let x equal that number, so 0.254, and then the thing is 5 and 4 are recurring, so it'd be 5, 4, 5, 4, and then dot, dot, dot. And the trick is, guys, with these questions, that you just have to keep multiplying in tens until you have some numbers that kind of look the same after this decimal. So let's do this. So let's multiply by 10x, yeah? If you do by 10x, you can get 2.5 and then 4, 5, 4, 5, 4, 5, dot, dot, dot. So far, the numbers don't line up. So if I multiply this again by another 10x, so 100x, we're going to have 25.454545 dot, dot, dot. So let's see. Do any numbers line up? Yes, they do actually. We can see that, hold on, let me change the color pen. We can see that the numbers in x, so these set line up after 1 decimal place. Now, so to explain this properly, what we're trying to do, we're just trying to get the same set of decimals because we're going to try and subtract 2 equations. We're going to combine 2. So for example, we're going to use the equation which is x and the equation which is 100x. And we're going to say, If we subtract these two equations, so equation 1 from 2, so 100x take away x, you'll be left with 99x. And if you subtract these decimals, you'll realize that all of these cancel out. So all of these decimals cancel out with this one. And you're left with 25.4 take away 0.2, which is actually 25.2. Okay, so that's what you're left with. And then to find x, well, just divide 99 across for x over 25.2 over 99. And thankfully, if you put this in your calculator, you're gonna get 14 over 55. And that's it. That's literally all they want you to do. It's just subtract two set of equations with the same lined up decimal, and you got the result. Now, 16. So here are the first 5 terms of an arithmetic sequence. So far they're all going up in threes, yeah? So plus threes. Find the sum of the first 100 terms. Okay, so this is different. Now, the sum of the first 100 terms uses a certain formula, yeah? So this is the formula. We have Sn equals the number of terms over 2 times 2a plus n minus 1d. Okay, so I'm going to explain what everything is. Here we got a, yeah? A is actually the first term. So in this case, the first term is actually 7. D is your difference, which is what is going up in. It's going up in 3. And n is your position. So what we're trying to say here, we want to find the sum of the first 100 terms. So in this case, n would actually have to be 100 because we're trying to work out 100 terms. Now, just put in a calculator. So we can say that S100 is going to be 100 over 2, which is 50. And then 2 times a, which is 14. Now, n minus 1, so 100 take away 1 is 99. And then we're going to have 99, let's just write down, 99 times 3. If you do that, you're just going to get a result of 15,550. And that's it, guys. Yeah, so far, not bad, is it? Alright, guys, number 17. So we got A and B are two similar vases. Vases or vases? Well, what do you guys say in your country? Because I actually can't remember how to say it. Vase or vases? Well, you let me know. Now, according to the info, the first vase has a height of 24. So let's just say 24. Draw the height of 24. Whereas the second has a height of 36. So this has a height of 36. Now, guys, before we look at the next piece of information, one thing to note. Because we're dealing with similar shapes, all that is telling us is that one shape is just proportionally bigger than the other. So I think the first thing we need to do is probably work out the scale factor. So I'm going to call the scale factor k, yeah? And I'm going to say that to work it out, you just divide the numbers. So the scale factor between b to a is 36 over 24. If you divide them, you just get 1.5. So it's telling us that shape B has a height which is 1.5 times bigger than A. Okay? Now, the next part, it says vase A has a surface area of 960 centimeters squared. Work out the surface area of vase B. Okay, so see how we just divided the lengths? If we're dealing with areas, then we need to use a scale factor squared. And likewise, if we do volume, it has to be the scale factor cubed. So for the scale factor squared, we start with shape B because that's what we did. So we can say that the surface area of shape B, let's just call surface area S, yeah, for shape B. And the surface area of shape A was 960, so surface area B over surface area of A, and it's supposed to equal a scale factor of 1.5 squared. Okay, that's exactly what it is. So this means that to work out surface area of B, you just multiply 960 across. So SB equals 1.5 squared times 960. Okay, and if you put that in your calculator, guys, you should get a result of 2,160 centimeters squared. Okay, and that seems legit because B is bigger than A, so you expect a larger area. Now for part B, it says vase B has a volume of V centimeter cubed. Find in terms of V an expression for the volume in centimeter cubed of vase A. So we're going to literally mimic the idea here. Yeah? Because we're dealing with volumes, instead of K squared, we're going to use K cubed equals the bigger shape, so the volume of B. So the volume of B, we say, well, he calls it V. And we want to find terms the shape of volume A, of vase A. So we're going to just call this shape, I don't know, VA, yeah? Just for the sake of it. Now what they want us to do, oh yeah, and this is supposed to equal the scale factor cubed, so 1.5 cubed. Now they just want us to more or less make the vars A the subject. So if I make vars A subject, I'll need to multiply this across. So it's going to be something like what? Wait, find in terms of V an expression for the volume in centimeter cubes for vars A. Yeah, so we need to make vars A subject. To do it, you just times VA across and divide 1.3 cubed across. So it'll be something like VA equals V over 1.3 cubed. Now 1.3 cubed is actually, I think you can leave your answer like that. It's 27 over 8. So it would be V over 27 over 8. And if you tie this up, because you got a fraction on the bottom half, if you divide a fraction, it flips upside down and you multiply. So it's going to become 8 over 27 times V. And that's it, guys. That's your result for vars A. Yeah. Alright, so question 18, guys, yeah? So the diagram shows triangle PQR, alright, right here. So you got two lengths and an angle. And they want us to calculate the length of PR. Okay, so straight to the point. Now, because you got an unknown length, let's just give it a name. Let's call it X, yeah? And the way to solve any single triangle problem in any single paper is to either use the sine rule or cosine rule. Okay, that's only for non-right angle triangles. Yeah, so we're gonna forget SOHCAHTOA, trigonometry, Pythagoras. We don't talk about them here. Now, which one do we use? Well, we always try the sine rule first, and the sine rule tells us that we need a matching pair of length to its opposite angle. So length to angle. In this case, we've only got x and its opposite pair is 36 degrees. However, we don't have another pair of angle. Because if we had two angles at least, and two lengths, then we can do it. But we can't. So in this case, we cannot use the sine rule. In this case, however, we can use the cosine rule. Because the cosine rule tells us that we need three lengths and an angle. And we got it. We got an angle and three lengths. Now, according to the cosine rule formula, if we have an angle, we have to call it A. Yeah? So this angle is actually called A now. This means that its opposite length to the angle has to be little a. So x is now little a. This means that the other two can be B or C. And it doesn't matter which order you call it. So according to the formula, guys, the cosine rule formula, it's actually like this. It's written as a squared equals b squared plus c squared minus 2bc cos a. Okay, and you can see that clearly capital A is the angle here. Now, because we have everything we need, we just substitute in, guys. So replacing little a with x, so we have x squared. B is 17.8, so 17.8 squared plus c squared minus 2 times, so I'm going to wrap these in brackets here. So B is going to be 17.8, C is going to be 26.3, and we got cos of the angle 36 degrees. And yeah, guys, now all you do is essentially just put this in your calculator, approximately, let's say 251, yeah? And now be careful, guys, because you want to find the length of PR. So you don't want to find x squared, you want to find x. So that means you got a square root answer, yeah? So if you square root your result, so just write in your calculator square root answer, you should get approximately 15.8 centimeters. And that's it, guys. It has to be 3 significant figures. Yeah. So, number 19. So it says that the table gives information about the heights of some trees. Okay, so you got heights and frequency, and it looks like we got about 15 trees with a height between 0 to 20, 48 between 20 35, and so on. Now on the grid below, they want us to draw a histogram for this information. Okay, cool. So guys, every time we're going to use a histogram, we always need to firstly understand what is the frequency density and what is the class width. Okay, so these are your two components you need. And I always like to draw like this. I always visualize some sort of x and y axes. I always draw a bar, because that's what histograms are. They're just nice bars. I always label the inside of it the frequency. So that's kind of like your area. And the width, I call it the class width. And the height, I call it the frequency density. Okay. Now, looking at this data, we only have the frequency. But we also got the class width. So if we add like another column here, call it CW for class width, we can see that the class width for the first group is between 0 and 20. So 20 take away 0 is 20, 35 take away 20 is 15, and so on. Next one is 5, and the last set is 10. Now I also like to include a frequency density, because this is going to be your y-axis, yeah? So that's what we need. We basically need the height of the graph. Now to calculate frequency density, from this formula, you can see that the frequency equals the class width times the frequency density. It's like base times height. This means that the frequency density itself is always equal to the frequency divided by the class width. Okay, so let's have a look. For the first one, we got 15 over 20, which is 0.75. 48 over 15, so just put that in the calculator, and you should get 3.2. Next one, 21 divided by 5 is 4.2. And the last one, guys, 16 over 10 is 1.6. Okay, and that's it. Now all you want to do is literally plot this on a graph. So conveniently, guys, they kind of did it for us. They put 0 to 5 for the frequency density, so our numbers look like they'll fit. And for the x-axis, they got, well, they call it a height, but this is pretty much our class width. It's these values here. So let's do it. So we can say from 0 to 20, there's area 15, so up to 20. We know that the height goes up to 0.75. So let's draw it. So we know that this is going to be 0.5, so 0.75 should be all the way here. So just draw a straight line hitting 20. And that's really it. And you're just going to repeat this every single time. So for the next bar, we're going from 0 to 20 to 35. The height is 3.2. So for between 20 and 35, that's what it was, right? 35. We're going to go all the way up to 3.2. So 3.2 is basically here. Yeah, and that's it, guys. You literally just have to rinse and repeat this. And that's it. And you're pretty much done. Yeah, so let's move on. Now, number 20. Okay. We've got A, B, C, and D are points on a circle. Okay, so before we even look at the shape, let's try and identify what it is. First things first, when we look inside the circle, we have a four-sided shape. So when you've got a four-sided shape where each point touches the circle, this is actually known as a cyclic quadrilateral, yeah? Now, one property of the cyclic quadrilateral, guys, is that the corners, the angles on each corner, sum up to 180. So for example, we can call this angle here A, and at point C, we can call it C. This tells us that A and C must sum up to 180, or B and D also sums up to 180. Okay. Another thing we can notice is that these two lengths appear to be the same lengths, yeah? So we'll come to that in a second. Now, according to the info, it says A, B, C, and D are points in a circle. TDV is a tangent to the circle. So tangent means it touches at one point. So we can see that this is angled at 71. Okay. The length of AB equals AD, so we saw that earlier. Work out the size of angle BCD and then give a reason for each stage of your working out. So guys, the only way to work out this angle BCD, so we're talking about angle C, is to somehow begin and relate angle 71 with the tangent and this random chord, yeah? And the only one I can think of right now is something known as the alternate segment theorem. And it looks a bit like this, the formula. The alternate segment theorem tells us that if you've got some angle B here, then and a tangent and some sort of chord, then wherever this angle is, it's going to be equal to the other side of it. But the shape has to be a triangle first. So let's just do it right now, guys, yeah? At the moment, we go quadrilateral. So let's try and rewrite this as a triangle. So you got your chord, you got your tangent. I'm going to draw a straight line from B connecting to D, yeah? Now this tells us that if you got 71 here, then on the other side of the chord, so we're talking about the other side, so over here, this angle here, just the first bit of it, let's call it X, equals 71. So not the whole B, but just this part. Now another useful property, guys, yeah, is that because you got some sort of like equal lengths here, we actually got an isosceles triangle secretly here. So this means that this part here is also 71 degrees. Okay. And because you got that information, you can now work out what A is. And we know that all angles in a triangle always adds up to 180. So we basically have A plus, well, 71 plus 71 gives us 142, and it's supposed to equal 180. This means if you minus 142 across, this angle A is now going to equal 38 degrees. And that's it, guys. Now finally, like if we go back to the cyclic quadrilateral rule, we said earlier that angle A and C sum up to make 180 as well. Now because we know that A here is 38, we can easily work out C. Well, if you subtract 38 to this one, you're going to go back to a C value of 142 degrees. And that's the answer, guys. The angle BCD is 142 degrees. And yeah, that's it. Alright, number 21. So a solid is made from a hemisphere and a cylinder. Okay? So the plane face of a hemisphere coincides with the upper plane face of the cylinder. Okay, so just to label this carefully, this bottom deck is actually the cylinder, and the top half is half of a sphere, so it's also known as a hemisphere. Okay, So we're going to see what formulas we need before we actually answer this. Now on the next part, it says that the hemisphere and the cylinder have the same radius. Now this is because they're both like decked up in the same way. So you can imagine there's a radius here, and the bottom half also has a radius like that, yeah? The ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. Okay, cool. So if we just imagine we've got some vertical height like that, yeah? Let's call it h. What he's trying to say here is that the radius of this shape, if you imagine as one part, must be equivalent to this side as if it was 3 parts. So this is basically 3 times the radius. So let's just call the radius x for a second, yeah? Let's let r equal x. That means the height must be 3 times x, okay? Given that the solid has a volume of 792 pi centimeter cubed, work out the height of the solid. Alright, cool. Let's have a go. So to work this out, guys, we just need to work out the volume of the hemisphere and the volume of the cylinder. Well, thankfully, we know both the formulas. We can say that the volume of the cylinder is just pi r squared height, h, and the volume of the hemisphere is actually half of a sphere. So if we know a sphere is just 4/3 pi r cubed, that means half of this would just be half of 4/3, which is 2/3. So if I just delete this one and just write 2/3, so just 2/3 of that shape. Yeah, and it's telling us that the combined total equals 792 pi. So let's write down here, yeah? We can say that the total volume V equals the cylinder, so pi r squared h. So instead of r and h, I'm going to place r of x and h of 3x. So it can be pi x squared and then 3x plus the other shape, the hemisphere. So 2/3 pi x cubed. And all of that's supposed to equal 792 pi. But we'll get to that in a second, yeah? Now, if we go ahead and multiply this term out here and just replace the volume with 792 pi, we now got 792 pi equals pi times x squared times 3x. That's just going to give us 3x cubed pi, okay, plus 2/3 pi x cubed. Okay, so when you look at all of these terms here, they each have a pi. So that means we could just cancel them out. So let's just delete the pi across. So these all cancel out. And then if we just tie this up now, we now got 792 equals, well, we're just left with 3x cubed plus 2/3 x cubed. Well, 3 plus 2/3 is actually 11/3 and then x cubed. And now we just rearrange to make x a subject. So in your calculator, guys, and we can do this all in one go, we can do 792 divided by that fraction, 11/3, and that equals x cubed. And then in your calculator, if you do that, you should get 216. Okay, so 792 over that is 216. And now, conveniently, if we cube root this, we're going to get a perfect answer of 6. And that's it, guys. We got x result 6. And remember, x here represents the radius, right? So to get the height, it's going to be 3 times x. So 3 times 16 means the height is going to be 18. So it's 18 centimeters. And that's it, guys. Sorry, guys. They want the height of the solid, not the height of the graph. So actually, the height of the solid is the whole thing up. So one more thing. So we know that this is the height. That means the radius, because we're dealing with sphere, if this is the radius, then this is also the radius. Because remember, it's the same all the way around. So actually, this length was 3x. Our height was x. So actually, we're trying to work out 3x plus x. So we want 4x. We want the total height, yeah? That means the final result, which is going to be 4x, is going to be 18 plus 6, or 6 times 4, by the way, which is 24 centimeters. And that's a real height, guys. The result here should be 24. Okay, let's go down. So the graph of y equals sine x for x between 0 and 360 is drawn on the grid. Okay, so here's our natural sine wave graph, where our peak is always at 1 and the other peak is at -1. And this is just one complete loop from 0 degrees all the way to 360. Okay. Now on the grid, we need to draw the graph of y equals 2 sine x plus 30 for x between 0 to 360. Okay. So how to convert a sine x regular sine to 2 times sine and x plus 30? Well, let's look at the first digit, the 2, yeah? What this tells us that the graph now is being doubled, okay? So to double this kind of graph, it just means that if the height was 1, we now double 1 to 2. So this means that the peak of this shoots up to here. And likewise, if the peak at the bottom was -1, then this now shoots to -2. Okay, so now we know how high it shoots. What about x plus 30? Well, this just tells you where the coordinates on the x-axis will shift. So this means that they all shift 30 degrees. Now be careful, guys. It says x plus 30. This doesn't mean you shift it to the right by 30 degrees. In fact, you shift it to the left by 30 because it's always inverted inside the bracket. So what I'm trying to say is that we're going to now move everything this way by 30 degrees. Okay? So if you think about, if we drew the original graph for a second here, so let's use a dotted line. This means that this point here would have been over here. This point here would have been over here. So it would have been something like this, 30 degrees to the left. And then likewise, this would have been here, this would have been here, and so on. So let's just see how it looks like. So this is going to be our peak. It shoots like that, hits at this point, 30 here, 30 to the left here, 30 left here, and 30 left there. So it looks a bit like that, guys. So here's our new peak up here, and you just follow along until it hits here. Perfect. So that's exactly where it should be. Now this was the 30 degrees to the left bit. So if we're going to shoot this upwards, this means that the new peak would be here, and the new bottom peak would be here. Okay, and the new 180 is going to be this over here, and likewise the new 360 is here, and this peak shoots up. Well, double this peak will go up to here. So let's try and plot this, yeah. And oh yeah, last one. This peak over here shoots up to here. So yeah, let's just have a go. So if I'm going to do this right now, I'm going to connect all the purple dots. So it's going to look like this, and then this one's going to shoot all the way down to here. And now we need to get to this point here. So it's going to just curve down here, curve back up, and then lastly end at this point here. Okay, so almost smooth, but yeah, that's basically the main idea. Just smooth it up. Now for part B, which is completely unrelated, guys. Write x squared minus 6x plus 10 in the complete square form, by the way. So this is always complete a square, where a and b are integers. Okay, so simply to complete the square, all I do, guys, is I always underline the first two terms, yeah? And now all you gotta do is also wrap this up in some sort of square format. The trick is to firstly open the bracket, copy the term x, and then half the coefficient of 6, so the number in front of the regular x. Well, half of 6 is 3. And then wrap that nicely in a square. And the second bit is copy out the plus 10, and then the final bit is to always subtract the thing you just halved. So basically square the 3. So it'll be minus 3 squared. And you're done, guys. And now we just combine the plus 10 and minus 3 squared. Well, in your calculator, plus 10 minus 3 squared, which is 9. So 10 take away 9 is 1. So our final result would be x minus 3 squared plus 1. And yeah, that's it. You complete the square. Now for part 2, hence describe fully the single transformation that maps the curve of equation y equals x squared onto the curve of equation y equals x squared minus 6x plus 10. Okay, so how do you move from here to there? Now keyword, guys, every time they use the word hence, it means use your previous result. In other words, use the result from BI, that one. Okay. So comparing y equals x squared and y equals x minus 3 all squared plus 1, we can see now that they've inserted a minus 3. So this is a shift in the x-axis by 3 points, and this is plus 1 outside. So it means it's gone up by plus 1. So a nice way to say this is that we can say that this entire transformation. So simply put, we can say that this entire transformation is a translation. Okay, so that's one mark. You say the word translation because translation means a movement. And you say a movement what? You can say a translation of 3 and 1. Now this vector means that, well, the 3 means that it's moved across the x-axis by 3 points, and the 1 means it's moved across the y-axis by 1 point. In other words, it's gone 3 to the right and 1 up. And that's exactly what this means. Yeah, and we're good here, guys. Now for 23, it says ABCD is a kite with AB equal to AD and CB equal to CD. I think it's good we just draw this right now, yeah? So you got kite, we just draw a regular kite, yeah? And a kite always has two equal lengths, two matching pair equal lengths. So for example, these two would be equal, maybe that looks horrible, and then these two would be equal. Now it tells us here that AB equals AD, yeah? So if we just wrote this as, I don't know, AB, and this one being AD, therefore we can call this one CB and CD. Okay, so this looks okay so far. Now it says B is the point with coordinates 10, 9. Okay, so we can say this one has coordinates 10, 19, sorry. whereas D is a point coordinates 2, 7. So this has coordinates 2, 7. Now find an equation of the line AC. So AC, AC. Okay, so it's straight line going down here. So we're talking about cutting it straight across. Okay, AC. Give your answer in that usual form. Okay, so easy trick for this, guys. Such an easy trick. The trick is that because you know kites have two pairs equal lengths, we can pretty much work out the length of BD, because BD is basically perpendicular. Even though my graph doesn't say so, we can work out length of the equation of BD and then just flip the gradient using the perpendicular rule and work out the length of the equation of AC. So let's do BD first, yeah? We can say for BD, we can work out the gradient of that line. Well, the gradient of that line is always the change in y coordinates over the change in x coordinates. And we need the points of B and D to do that. So looking at the points of B and D, we can say that, well, the change in y coordinates would be 19 take away 7, which is 12, and 10 take away 2, which is 8. Okay. And well, you could simplify that if you want, yeah? But we could do that in the next step. Therefore, we can say that for line AC, this is clearly perpendicular. So that means the gradient for this line will be the negative reciprocal. And that's what you do. So negative reciprocal means you flip it upside down and then you flip the sign. So it becomes a minus 8 over 12. Yeah. So that's good so far. And just for the sake of it, guys, we should simplify the fraction. And you should get now minus 2/3. Now we got pretty much our gradient here, guys. So what's next? Okay, so let's write our equation out. So the general form of equation, and this is a straight line, yeah, is always y equals mx plus c. So updating this, we have y equals minus 2/3 x plus c. So our final step now, guys, is to literally figure out a point for a coordinate on this line to work out c. Now the question is, where do we find it? Well, conveniently, guys, you can see like from the shape of the kite, the midpoint is actually halfway between B and D, and also halfway between A and C. Technically, we can just work out the midpoint of B and D, and that's a perfect point on the line of AC. So let's work out the midpoint, yeah? Let's call this midpoint M, yeah? So we can say to work out any midpoint, the trick is to literally add up the pair of coordinates. So for example, add up 10 and 2 for an x coordinate, and then half it. We can see that 10 plus 2 is 12, so we've got 12, and we half it. That gives you x coordinate. For the y coordinate, we do 19 plus 7. That should give us 26, and you half that as well. Therefore, resulting each one, 12 over 2 is 6, 26 over 2, guys, is 13. And that's nice, because that's a point on the line. Now, we're going to substitute this coordinate into this line, and then solve for c. So this means when x is 6 and y is 13, we can put this in. So replace y and x with 13 and 6. We should therefore have 13 equals minus 2 over 3 times 6 plus c. And yeah, guys, now if you just word this out, you can see that minus 2 over 3 times 6 in your calculator will give us minus 4. Scroll this down a bit. And then, you know, copying out the rest, you got 13 and plus c. Therefore, adding 4 across, guys, you should get c value of 13 plus 4 is 17. And yeah, I think we're basically done now. So now we know what c is, so we can update our equation once more. So it's now going to look like this. We now got, therefore, y equals minus 2 over 3x plus 17. Now going back to the question tells us to give your answer in the form of py plus qx equals r, where p, q, and r are integers. Okay, so rule 1, we got to put x and y on both sides and make it equal to a number, and then clear out the fraction because they don't want fractions. So let's do it now. Let's move 2/3 x across so we can add it across. So it look like, where is it? Y or x first? Okay, y is first. So it's going to become y plus 2 over 3x equals 17. And now all you want to do, guys, is literally clear the fraction. So to clear the fraction, if you got a 3 at the bottom, just multiply the whole set by 3. If you do that, you're going to get 3y plus 2x, because the fraction is cleared. And then 17 times 3 is 51. And that's it, guys. This should be a result. 3y plus 2x equals 51. Now, let's go into number 24. So this is actually the last one, guys. And you know what I like about this? They actually don't waste any paper for once. Because they always have like, you know, blank page or something. Like, who does that? Alright, number 24 though. So a particle P is moving along a straight line that passes through a fixed point O. The displacement S, so displacement is pretty much a vector form of distance, like how far you travel from a certain point, of P from O at time t is given by the following equation. So S is your displacement, T is your time. Find the value of T for which the acceleration of P is 3 meters per second. Okay, so this is secretly a differentiation question in disguise, yeah? And how to figure this out? Well, you always have three components. You have the displacement, you have the velocity, and then you have acceleration. And to get to each component, you have to differentiate across. So to go from S to V, you go differentiate. To go from V to A, you differentiate again. So essentially, we need to differentiate this equation twice, guys. So let's start with that. So let's work out velocity first. To do that, we need to differentiate the S equation with respect to T. So differentiating this equation, guys, to differentiate, all you do is literally drop the power and then subtract the power by 1. So for T cubed, it becomes, you drop the power, you get 3T. Subtract power by 1, you get 2. That's it. If you got a number in front, do the same thing. Draw the power, so you got 2 times 6, which is 12. And then subtract power by 1, you got T to the power 1, which is just T. Now, if you just left it with a T on its own, that vanishes, so you got 5. Yeah, just 5. And then if you got a constant, well, there's no T, so it becomes 0. And you left it like that. Now, to get acceleration, guys, again, we go differentiate this equation with respect to T. Doing the same thing, drop the power. 3 times 2 is 6, you got 6T. Because you just got a T left, it would just be minus 12. And yeah, guys. Now, the final step, guys, is that looking back at the question, it says find the value of T for which the acceleration is pretty much equal to 3. In other words, replace A with 3 and solve for T. So since A is 3, copy the whole equation. So you got 6T, why is it slowing down? Minus 12. Okay, hold on, is it working good? Yeah, it's working. So to find T, just solve for T. So add 12 across, you got 15 equals 6T. And lastly, guys, just whip out your calculator. Just write 15 divided by 6. And you should therefore get a T value of 2.5 seconds. Because remember, this is time, yeah? And we're done, guys. That's pretty much the whole paper done. And that was probably the easiest, I think the easiest final question we've seen in the new 4MA1 paper series. Usually they always give you a summation or some kind of really hard arithmetic question. But today, man, they gave you a nice one. So yeah, not too bad. Not too bad. Anyway, I hope you guys enjoyed my video. If you guys enjoyed it, please give me a like. As usual, share with your friends and subscribe. Try and help me reach more subscribers, guys. So, more people that get a chance to watch this, they can benefit. And, I'm trying to reach this across the whole world. So at least everyone can, inshallah, have a watch on this and, hopefully improve their maths or anything else, And if you get stuck in questions, guys, just drop me a comment and I'll do my best to answer it when I can. But yeah, as always, thank you so much for tuning in and watching my video, guys. I really appreciate it, and I'll see you guys in the next one. And that's it. Ciao.